Hello, my name is Glenn Steeper. I'm the Technology Manager for the Mineral Processing Division with Glencore Technology, and thank you very much for tuning in to listen to this presentation today. Today I wanted to discuss the challenge going forward with the degrading ores and also the need to maintain or even better performance in the industry. So I was going to touch on some of the solutions that Glencore Technology may be able to offer for this problem. So one of the first concerns or issues is the increasing complexity of ores. We know that a lot of the easy, sort of low or high grade accessible ores have already been mined or are currently being mined. What we also know is that the current stocks of the unknown or underdeveloped ore bodies are becoming more and more complex. If you look in the graph over here, you can see that since the 1900s, you can see that the grades of the copper globally is decreasing, and this is adding to the need to look at doing higher throughputs to try and maintain the same metal quantities. We also know with this type of trend moving forward that the future will be lower grades, deeper and larger capacity, and also bigger footprints. We also know that mining industry has capitalized on the rising metal prices. And also with these larger plants, it means that the higher prices are often overlooking the environmental and even the social costs. You can see here that on this graph, it's showing the value of the discoveries in recent times. You can see here it's heavily depleting, and this also follows with the expenditure. So what this also just cements is that the problems we are facing in the future in mining is becoming greater and greater. So the other point is there is a lot of pressure and trends in the industry to look at the environmental and also to reduce capital. A number of the large firms such as the World Economic Forum and Deloitte have stated that there's a lot of pressure on stakeholders for less environmental impact. Deloitte talks about the trend towards production in a sustainable way and also demand for environmental and safety performance. We know that since the lockdown from the COVID, there's been a sharper focus on the carbon emissions with predictions of up to 17% down in April, and also with the demand for less capital and also less OPEX. So what is the problem and what is the challenge? So the problem is twofold, and it really talks about the two trends that I just mentioned, and also how we need to process more in a sense for less. So the challenge is to innovate the milling and flotation and the circuit really as a whole, and also to process the same or greater throughputs using less equipment and less energy. So Glencore Technology has been around for a number of decades, and we have 5 core technologies which we have been marketing and delivering into the mining industry for many years. The two that I want to talk about today is our mineral processing technologies, which is the IsaMill and Jameson Cell. So we talk today about the full circuit application and some of the innovations that we have now moved into. So the first part is where we're trying to move into to solve this problem. And this is around innovations within our milling and flotation technologies. It's also around looking at smaller footprint, and it's also with lesser energy and increased throughput. So these are what we've looked at, and these are the types of things that we've taken on as a challenge to solve. So how have we done this, and how are we now taking these things and take it into practice? So I'd like to sort of introduce a new project which we have recently been awarded. And this is a large lead zinc concentrator, 875 tons per hour in Siberia, Russia, called Ozorne. This circuit is potentially the largest lead zinc operation to come online in the last 40 years. So it's a significant addition to the market. It replaces 63 conventional tank cells with 19 Jameson cells. So it's a complete 100% Jameson cell circuit. It reduces the footprint by doing this by over half, and it also reduces the power by half. And as you can see here, that these Jameson cells have no agitators, So there is no need for lifting in terms of inside buildings. So it means the height of the building and craneage in this case was 15 meters lower. So there's a lot of savings, not just in footprint, but also in the height of the building. Another big thing for this project is the introduction of a new IsaMill to our models. This is a M20000 IsaMill, and there's 3 supplied for this project, and they are now supplied with 5 megawatt motors. This circuit will be commissioned in Q4 2022, so next year. So it won't be long before you to see this actual plant up and running. So this is just a quick schematic of what the circuit looks like compared to the conventional circuit underneath. And you can see here, this is where the 50% footprint reduction comes in. So I wanted to just quickly flick across and just show you what this looks like in the 3D model. So this is the circuit here. As you can see in the front, this is where the 3 M20000s are positioned. And then towards the back end here, or the front end, I should say, we have the 2 rougher scavenger in the lead, followed by lead cleaning. And then we have 5 of our large zinc and pyrite rougher scavengers down here with a very high mass pull of around 55%, floating a lot of the pyrite out as well. And then the fine grinding, we go down to between 10 and 13 on the zinc and 10 and 7 on the lead. And the circuit in the back end here is basically the pyrite rejection and the upgrading of the zinc concentrate. Sorry. So I wanted to also quickly mention another circuit which we will be bringing online later this year. And this is again a 100% Jameson Cells circuit, which goes from 11 conventional cells replaced by 4 Jameson cells. So it's a smaller circuit, it's 70 tons per hour, but again, it's on that similar sort of principle where it's less than half the footprint. So a big reduction in capital and a big reduction in the footprint and savings around that area. As I mentioned, commissioning is in Q4 this year. So what does this mean for the industry, or what do we believe these sorts of circuits now represent to the industry? And we see that the low-profile Jameson Cell and IsaMill plant layout have major costs and safety benefits. Reducing it to the ground is no longer working at heights, a lot less of those sorts of safety concerns. It's also, there's no blowers or agitators, and with a high-efficiency grinding, makes for significantly lower power consumption. We also see more than 50% footprint savings, meaning significant capital savings. And also a significantly less equipment means less spare parts and maintenance requirements, which means in a sense, it's less capital cost. Sorry, OPEX cost. And over the 30 years really of proven technology, so the IsaMill and Jameson Cell, we've now have over 130 IsaMills and over 420 Jameson Cells. So it's a very proven technology in many applications around the world. And really the circuit and equipment is operationally is very simplistic. So it means that you get consistent high performance. So some of the developments of these technologies in terms of over the recent times and how it sort of enabled us to get where we are today. So as I mentioned earlier, this is our new M20000 IsaMill, the 5 megawatt motor. So you can see here just a quick layout and the new low profile, and also this removable platform. A bit more detail around that. This is our old design here, and some of you will be quite familiar with those out in the industry. These are where we have the ISA charger underneath the mill, and also on the high sort of structure around up to 5 meters high. What we've now moved to is a much lower platform. We've moved the ISA charger and tanks to the side, so it means we can bring the IsaMill right to the ground. In this case, it's down to 1 meter above the ground. The platform here is also removable, so it means that whilst you're not actually doing maintenance on the mill, you can use this laydown area for other parts. The reduced footprint and the reduced to the ground also means no working at height, so a lot of safety benefits there as well. When you take this all into account and then you sort of lay this out in front of a typical vertical stirred mill, you can see that we sit within their footprint on the ground, but obviously have a lot less height worries. So there's no working at heights and there's no working under loads. So one of the benefits there with going up in terms of the size of our IsaMill models, as you can see here, that as we're going up, basically the size is delivering more energy per unit area. So what this essentially means is that you're getting more throughput with less footprint. So some of the stuff we've been doing with the IsaMill in particular is a lot of R&D, extensive R&D over the many years. So we've trialed many types of different compounds over the last 25 years, which has resulted in a world-leading understanding of best practices. So we will try many different rubbers, and we understand exactly how they wear and how they basically run in different applications, whether it's gold, whether it's the type of abrasiveness of it. So we have a very, very good understanding of what's best for each individual operation. We also have done extensive work on grinding disc design, so looking at ways of reducing wear rates and also looking at increased efficiencies. If we look at just a general look at our marketing, so we've got a very strong global presence and we're expanding. We've continued to develop new products, and also we have very good support to Glencore sites and also our other partners and suppliers around the world. New models have been brought online, and a lot of those is from listening to the feedback from clients. We understand we had some gaps in our sizes, so we've made sure that we've developed new ones to try and fill those gaps. And just some comments here. The Red Dog has just been commissioned successfully. So this is the M15000 in Alaska. And also we'll obviously be commissioning 3 of the M20000s next year. Just going to quickly touch on the Jameson Cells. So this is obviously a big enabler in with our technology in the full circuit. So we have now developed a new 8512 downcomer cell. This comes in both the B and Z cell designs. This one shown here is the Z cell design, and the B cell design is with the ERM and the hopper underneath, which is more of our traditional design. This unit here pretty much doubles our capacity compared to our old B6500 designs. So it now means we can treat up to around 1,500 tons per hour in a single unit. So it really opens the door to very high throughput, low grade applications. This unit itself is being installed in Cadia with Newcrest later this year. So this will be a great thing for us to commission. And we also have 7 of these units in the B cell design, which has been installed for the Zorno project next year. So just a quick touch on just how we actually take the information and then would go forward to design a full circuit like we've just discussed. So if you look on the side here, this is actually raw data from an actual site. And this was a demo rig that was installed. And this is the tank cells that we're currently running that are installed on site as well. And this information here then is transferred onto here. This grade recovery curve you can see here is our 3-stage dilution cleaning test, which can be done in any lab anywhere around the world. And you can see here that this particular rig was operating this point on the curve. We could obviously run this Jameson cell anywhere on this curve, depending on what sort of setup we would run it at. And if you look here, if we look at a rougher, this would be a rougher scalper, because if you look at the line here, which is the target concentrate grade, all this material here is currently liberated and can go directly to final concentrate. The second one here is sort of borderline. This would be your rougher material. So we would, again, operate this in a slightly different way. We would look at a medium froth level. We would look at medium froth wash, and also to do with the air to pulp ratio. Down the bottom, we have the scavengers. This is our non-liberated material. And again, we would function and run this as you would a typical scavenger in any unit, where we would have very low levels, froth levels. We would look at very high air to pulp ratios, low wash wooding, how you would typically look to try and rip as much as you can out. This is all very efficient and done with zero short circuiting, which is why we can get away with such a small amount of units. So just a quick look at what we actually have on offer. So we can see we go from 27 cubes all the way up to 3,360 cubes. So we have a large range of Jameson cells to offer and to cater for all needs. So what do we believe this now offers to the mine industry? So we believe that it offers an environmentally friendly response to the needs for a sustained or improved metallurgical performance for increasingly challenging ore bodies. It significantly reduces a reduction in CapEx and OpEx, improving the financial viability of treating low-grade and high-throughput applications. It also simplified the flow sheet and operations, so it delivers high performance, but even in regions where resources may be limited or the locations may be quite hard to get to. So it also looked at reducing the energy requirements, which helps in locations where there may be power limitations. And we see this as actually a major step change for the industry. So thank you very much for listening to my presentation. If you have any questions, feel free to drop us an email at the 2 email addresses below, or visit our website and we'll be happy to get in touch with you straight away. Thank you very much.